Hello parents and carers. The aim of today's video is to show you how we do maths in Year 4. Today we will be looking at the 4 operations: addition, subtraction, multiplication and division. We will be going through an example of calculation for each of these and an example of reasoning for each of these. I hope you find this video useful for when you are helping your children at home. So we're going to start with addition. So when we are adding, we use the column method, and we make sure that we always start with the smallest value digit. In this case, it's our 2 5s. So we would do 5 plus 5 gives me 10. I would write down the 0 and carry the 1. I then move on to my next column, where I've got 4 10s and 5 10s. 4 10s add 5 10s is 9 10s, and then I add the 1 which I carried on previously, which gives me 10 again. I put down the 0 and I carry the 1. Then I've got 7 add 4, which is 11. I then add on my 1 which I carried on previously, 12. So I've got 12 hundreds. I put down my 2 and I carry my 1. And finally, 8 plus 3 gives me 11, add 1, 12. And now because I've got no digits left, I can simply put my 12 down. So my answer is 12,200. We're now going to have look at an example of laying out an addition problem in column method which involves decimals. This is something which we find quite tricky in Year 4. So the first thing that we need to do is we need to think about our place value columns. So we start with our hundreds, our tens, our ones. We then have our decimal point, our tenths, and our hundredths. And once we've got that, we can lay out our digits in the correct place. If I look at my first number, 748.4, I can see that I've got 7 hundreds, 4 tens, 8 ones, a decimal point, and 4 tenths. Now moving on to the second number, 38.34, I can see that I've got 3 tens, 8 ones, my decimal point, 3 tenths, and 4 hundredths. It's really important here that we make sure our decimal points stay in the same place. If we line up our decimal points, the other digits will fall into the correct place. So now, again, I start with my smallest value, which in this case is my hundredths. I can see that in my second number, I've got 4 hundredths, but in my first number, I don't have anything there. Not having anything is the same as having 0. So I can now do 0 add 4 is 4. 3 add 4 is 7. I remember to put in my decimal point. 8 add 8, which is 16. I put down my 6 and I carry my 1. 3 add 4, which gives me 7. Add my 1, 8. And 7 add nothing is 7. So my answer is 786.74. This is particularly useful when we are looking at adding money. Moving on to a reasoning question. We've got this example here. Here are 3 digit cards. Alex and Teddy are making 3-digit numbers using each card once. Alex says, I have made the greatest possible number. Teddy says, I have made the smallest possible number. Work out the total of their 2 numbers. For this question, because it says total, we are going to need to add. But we have been told that we need to add the smallest possible number and the greatest possible number. And before we can add, we need to work out what these are. To do this, we're going to use our place value column again. It's important to know the value that each digit has in this case. To make the greatest possible number, I want my greatest digit in my greatest possible value. So in my hundreds, tens and ones, hundreds is worth the most. So I'm going to take my biggest digit, which is 4, and put it in my hundreds column. I then look at my next greatest value, which is my tens. I take my next greatest value digit card, which is 3, and I put that in my tens. Finally, I've got my ones and my last digit 2. Here we have made the greatest possible number. I then need to move on to making the smallest possible number. I'm going to do the same thing, but this time in my biggest value, I'm going to have my smallest digit guard. So in my hundreds, I'm going to have 2. In my tens, my next smallest is 3. And in my ones, I'm going to have my biggest, so that each of these digits has a much smaller value than they did in the first question. Now I have been asked to find the total of the two numbers. So I'm going to add these together to find the total. 2 plus 4 is 6, 3 plus 3 is 6, and 4 plus 2 is 6. The value of my digits is 666. I would then encourage the children to write a sentence to make sure that they have understood that they are actually answering the question. This helps to encourage the children to think about what they have actually done in the question and to see if it is actually answering what the question has asked me to do. So I would write the total of their two numbers is 666. We also encourage children when they are using their maths books to make sure they are putting one number per square. This will help organisation and it will help them to see where their numbers are when adding or subtracting or multiplying or dividing. Now moving on to some subtraction. Again, in subtraction we lay out our question in the column method. We make sure to start with our smallest value, which is in this case our 5 and our 1. So 5 take away 1 is 4. Moving on to our next column, we have 4 take away 7. We need to remember that we cannot take away a bigger value from a smaller value. If I've got 4 apples, I can't possibly give someone 7. So in this case, we need to exchange. We need to go to the next column and we need to exchange 100, so now we've got 400s, and make that into 10 tens. So now I've got 14 tens, take away 7 tens, which gives me 7 tens. Again, we've got 4, take away 6. We can't do that, so we need to go to the next column, which in this case is our thousands, and we need to exchange 1,000, which leaves us with 6 thousands, into 10 hundreds, which gives us 14 hundreds. 14 hundreds take away 6 hundreds is going to give us 8 hundreds. And finally, 6 take away 4 will give me 2,000. So my answer is 2,874. Again, I would like to show you a subtraction question using decimals and using carrying over. Now in this case, when we are looking at money, often we will end up with a whole number take away a decimal number, because we usually, when we would go to the shops, we would have maybe a £10 note or a £20 note, £5 note, and then we'd have to take away from that. So again, our place value column grid comes into effect here. We put down our hundreds, our tens, our ones, decimal point, tenths, hundreds. Looking at our 100, it's important that we put our digits in the correct places. 100 has 100 in it. It's got 0 tens and it's got 0 ones. After that, we can fill in the rest after the decimal point with placeholders. If we put in our decimal point, we can put our placeholders. This will help with understanding that the digits have a different value. And it will help us when we come to take away that 60p. Next number we have is 45.60. So we've got 4 tens and 5 ones. We've got a decimal point, we've got 6 tenths and 0 hundredths. Now we can take away. We always start with our smallest digit, which in this case is our hundredths. 0 take away 0 is 0. 0 take away 6 we can't do. So here I'm going to show you an example of exchanging through the zeros. I go to my next column, but I've got 0 there as well, which means that I can't exchange from 0. So I move on to my next column, which is my tenths, and again, I've got 0, I can't exchange. So finally, I go to my hundredths, and I can exchange 100, leaving me with 0 hundredths, but 100 would make 10 tens. So I need to make sure I am exchanging into the column next door. I then go to that column and I exchange 1 10, leaving me with 9 tens, into 10 ones. And again, I can exchange from my ones, leaving me with 9 ones, and I exchange 1 1 into 10 tenths. I now have 10 take away 6, which leaves me with 4. I need to remember to pop in my decimal point, and then 9 take away 5, which gives me 4. I've got 9 take away 4, which leaves me with 5, and I've got 0 take away nothing, which leaves me with nothing. So my answer is £54 and 40 pence. Now moving on to a reasoning question. We're going to have a look at this reasoning question here. Eva is working out 406 take away 289. Here is her working out. Her step 1 and her step 2. We have been asked to explain her mistake and what the answer should be. So we're going to look at this question, and we can see automatically in step 1, she has exchanged into her ones column, but she has exchanged from hundreds. Now, because we know our value of our digits, we know that 100 is not the same as 10 ones. In fact, it is the same as 100 ones. So, what Eva should have done would be exchange from her hundreds into her tens first. And then from her tens, she would exchange 1 10 into 10 ones, giving us an altogether different answer. We would do 16 take away 9, which gives me 7. 9 take away 8, which gives me 1. And 2 take away 3, which gives me 1. So in fact, the answer is 117, not 27. Moving on to multiplication. And we can see that we have laid it out once again in the column method. When we are looking at multiplication in Year 4, we are looking at 3 digits multiplied by 5 digits. So we are going to look at our multiplication number, and we are going to multiply each of our top numbers by the same number. So I start with my ones. 5 times 4 is 20. I put down my 0 and I carry my 2. 5 times 4, I'm moving on to my tens. And 5 times 4 gives me 20, but I need to remember to add this 2 which I carried. So that gives me 22. I put down my 2 and I carry my other 2. I'm now doing 5 times 3, which gives me 15, and I add my 2 on, which gives me 17. Because I've got no other digits to multiply by, I can put my 17 straight in without carrying my 1. Now on to a reasoning question. If 3 times 5 is 15, which number sentences would you find the answer to 6 times 3? Now in this question, the children should understand that multiplication is the same as repeated addition. So if I'm doing 3 times 5, that is the same as 5, add 5, add 5. Or 3, add 3, add 3, add 3, add 3. So then if I am now multiplying by 6, the children should understand that I am simply adding another 3. Which means that 6 times 3 is the same as 5 times 3, add 3. It's also the same as adding 3 to my answer. So 15 add 3. And because of our commutative law, we know that 6 times 3 is also the same as 3 times 6. And they would be able to explain this using by showing they're working out like this, or by writing a sentence. I know that 3 times 5 is the same as adding 3 5 times. So if I would like to do 6 times 3, I'm going to need to add an extra 3 to my 5 times 3. I also know that in multiplication the numbers can switch around and it still means the same thing. That is the reasoning that we would expect from a Year 4 child. Moving on to our division. In our division we use the bus stop method. And I always encourage the children to first of all look at the digit that they are dividing by and to write down that times table or have that times table in their head ready. So I would write down 6, 12, 18, 24, 30, 36, and then I'd probably stop there and see if I needed to go further later. So we look at our first digit, which is our 7, and what we would do is we would find the number in our times tables which is closest to 7 without being more, and in that case it is our 6, which shows me that 6 times 1 will give me 6, so it goes in 1 time, and then I need to find my remainder. So to get from 6 to 7, I would add 1. So 1 is my remainder number. Now I'm going to look at my next digit. I've got 13. 6's into 13. I look on my times table and I see the number which is closest to 13 without being more. And in this case it is 12. So I can see in my times table 1, 2, 2 times 6 gives me 12. And again, from 12 to 13, I would need to add 1. Or I can do 13 take away 12 leaves me with 1. So I need to carry over my 1. And then I look into 6 into 10s. The number closest to 10 without being more is 6. So that means I can make one group of 6, and then I would need to see how many I have left over. So 10 take away 6 leaves me with a remainder of 4, and we just simply show that in Year 4 with an R4. Now moving on to our reasoning question. Which calculation is the odd one out? Explain your thinking. Now, the thing about reasoning questions is that they can have more than one answer. So, the children could say that 64 divided by 8 is the odd one out, because it's the only one with 2 even numbers. They might say that 65 divided by 3 is the odd one out, because it's the only one being divided by an odd number. Or they might work out our answers. They might say 64 divided by 8 is the same as 8. They might then work out 77 divided by 4. Ooh, not so sure about that because it's not in my times table. I'm going to use my bus stop to work that one out. And I'm going to figure out that 4's into 7 go once with a remainder of 3. And 4's into 37. Ooh, I'm not sure about my times tables that far, so I'm going to write down my times tables to support me. 24, 28, 32, 36. Oh, and I know I'm not going to get to 37, so I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, okay. So 4 goes into 37 9 times with a remainder. So it's 19, remainder 1. they might then do 49 divided by 6. Again, they might get a bit stuck. They might then use their times table chart that they might have. And they would figure out that there's a remainder. And again, with 65 divided by 3, there is a remainder. So again, that leaves us with 64 divided by 8 being the odd one out because it is the only one without a remainder. As long as the children are explaining their choices, they could have chosen any one of these 4 to be the odd one out, as long as they have a valid reason for it and that they are explaining it fully. Well, I hope that this video has helped you understand how we learn our 4 calculations, 4 operations in Year 4. Thank you for watching. Bye now.